Alright, so we're going to be making a One Pin Keypad example project today. And that example project is a safe. So, let me take you through all the things that we're going to need to accomplish this. Ready? Let's go. So, first we're going to need a keypad. This will accept the passcode from the user and allow them to open the safe. Next, we're going to need an Arduino Nano. It will serve as the brains of the operation, and we'll use it to control everything. Next, we're going to need this, a breadboard. This is where the Arduino is going to live, and it's pretty small, but it should do the job just fine. Next, we're going to need something to communicate with the user. Well, you guessed it, it's a 16 by 2 character LCD. This one's a little special, however, and I'll show you why. It has an I2C backpack on it. This simplifies your wiring and makes it so you use less pins on your Arduino. I'd call that a win-win. Next, we're going to need a 24 volt 500 milliamp power supply. Now, this is going to be used to power something else. This is going to be used to power this, a solenoid. Now, this solenoid is going to act as a lock or latch for our safe, and will keep our things safe, hopefully. Now, you can't exactly connect your Arduino directly to your solenoid. You're going to need some components, namely, to accomplish this task. This is a MOSFET. So a MOSFET is basically an electronic switch. This one specifically is an NTE 2396. So this will allow us to control our solenoid with our Arduino. Next, you're going to need a diode. Now, when a solenoid turns off, some current from the collapsing magnetic field flows through the circuit. Now, this could damage some of the components, so we're using the UF4007 diode, pretty standard, to prevent this from happening. Now, that is pretty much everything we're going to need for the case, for the safe. Except one thing. Oh, I just said it. Case. Now, this case is really high tech, so prepare for the grand unveiling. I spent a lot on this, so don't make fun of me. Yeah, it's a cardboard box. Pretty luxurious. This one's recyclable, you know? Don't see that every day. And while this might not be the most secure thing, it'll be easy to machine, and the mechanical part of this project isn't really the focus. It's more electrical. We're focusing on the One Pin Keypad, but this is just an empty box, and we're gonna make a safe out of it. And I know you can break into it with a box cutter or scissors, but we'll call that a feature and move on, shall we? Alright, so into the build.
Here I'm making holes for the LCD screen using just a drill bit without a drill, but how you do this is up to you.
I know, no promises, but you know, it's about the right size. Just hot glued on there because that's classy. And just pull it off. I don't know, I can see that. Alright, so I decided the phone was a little too big. So off camera, did a little bit of liberal bending using some pliers.
This piece of clothes hanger is basically to prevent the safe from just being open from the outside, so the latch stays in place by sticking through it, and then you can't pull it out. Instead of soldering, I used some spring terminal connectors to connect the wires together. Here's the fritzing diagram I used to connect this all together. After finishing my wiring, I realized I still had a problem. The wires going to the LCD were getting in the way of the door closing, so I routed them around the LCD itself. Here's a quick close-up. I also added some hot glue to the power wires for strain relief.
To make a small safe, just inspiration, so you can see the other solenoid down there. This is way smaller. It's kind of cute. But yeah, you could probably make a similar safe. I'd use wood or something. People could always steal the safe if it's this small, but I don't know, cool ideas. Or using an actual proper lock solenoid. But yeah, this is it. Also, there's another project coming to Progetto Company. It's a kit. And it's for solenoids. So stay tuned, because we're probably going to remake this with the solenoid kit.
Alright, so I'm just going to quickly go over the code. Yes, there's code comments, but I thought I should take the time. So, first, some quick things. So, I've included the libraries here. You're going to need to set up the One Pin Keypad, and there's an Instructable on how to do that here, and that's basically so you can get the analog thresholds. Basically just calibrate it. Right, so just here there's some constants. This is your password. You can change it to your liking. This one's not very strong. And then there's some other user settings, so how long until it automatically locks again, and how long until the safe automatically self-destructs. You'll see what I imply there. The I2C scanner sketch, just look up I2C scanner, and then you basically you plug in your I2C LCD and get its address, which you put here. Apart from that, that's pretty much it. And then there's just some booting up stuff, some initialization. This is a countdown function. I'll get back to that in a second. Apart from that, in the loop, we start by basically just preparing an array to store the user input, and then we grab the user input here, and when you're done entering your password, you hit pound, like an enter key on your keyboard, and then we check the password later. This is just it displaying the password, and all the stuff has to do for that. So it compares, and if you get the password right, it unlocks the safe using the Solomon pin, and it'll lock again. And you'll notice that the countdown function is called here, so it basically just updates the display as it's counting down to 5 seconds, 4 seconds, 3 seconds, all the way down to 0. If you get the password wrong, we're going to make the potential safecracker run through their lives, or their box knife. It's basically just said self-destructing in so many seconds. And so you set that at the top, and again, the countdown function is here. Pretend to glitch out, and then we laugh about it before resetting. So the countdown function, really quick, basically just the coordinates on the display. So it's a 16 by 2 character LCD. So the first row is 0 to 15, second row is 0 to 15 X, and then it's by Y. So the first row is 0, and the second row is 1. So there's a Y values. And then the timeout is how long in seconds you want to wait. So that's pretty much it. If you have any questions, ask in the comments.
I think it's time for a demo. First, we're just gonna enter the password. It's a really strong password, so take notes. So we're gonna hit pound. So if you heard that click, it's hard to do one-handed, but there's it's open, and then it locks again automatically. You can change the timer. So to close this, actually, very beautiful in there. So to close this, actually, you have to enter the password again, unfortunately. There we go. It's unlocking. Close it again. Okay, so I'm gonna try to close it out. And perfect, so it's locked again. Now I decided to add a little extra, and that is you just fill the screen. You can enter whatever you want. I'll just click some random buttons here. So there's my wrong password. I hit pound, say wrong password, and then it'll say self-destructing, and then countdown. And I'm not actually sure why it does those random numbers at the end, but I don't know, it went with the glitchy effect. So this is pretty much done, and if you didn't notice already, this whole video was sponsored by Progetto Company, the makers of the One Pin Keypad, and so that's why I decided to make an example project. And full disclaimer, it is my company, so yeah, that's how I got a sponsorship on my second video. So thank you for watching, and please consider subscribing. Thank you.